Alright, hey guys, how's it going? My name's David Martin, and today, whoop, that's better. Today we're going to be developing Middle Realms a little bit. First things first, I want to quickly set up the Trello a little bit better just with today's stuff. These are both done. This is actually canceled because the architecture was modified a little bit. That's done. So now ECS is pretty much fully implemented. Hey Gabe, what's up? ECS is pretty much fully implemented at this point. So now it's time to kind of resume the creature phase. We kind of started off from scratch. There's some choices I made with the animation system that I did not like. So we might kind of just completely redo that system. Hey Joya. So we're going to cancel all this stuff here. Well, not really. But we're going to say create creatures. Well, yeah, I'm going to create behavior component with random movement. Actually, that's already partially done. That's in progress, I guess. How's everyone doing today? Then we want to generate models and animate. Okay, cool. Yeah, then that. Yep, okay, so this is maybe this. Let's make a new, oops. Actually, purple's fine for that color, yeah. Okay, cool. Okay, so we're gonna head back into Game Maker Studio 2. And we're gonna quickly take a look at what we have so far. Actually, no, we're not. So when we're creating a creature already. Yeah, I understand, buddy. It's gonna be that way for a bit, unfortunately, or not for a bit, forever, but you'll get more used to it. Okay, so we're generating a model here. It's totally placeholder. And this is the code, the totally terrible code that we're using to generate these creatures. Not generate, but birth a creature into the world. We're gonna set its creature component real quick. So we're gonna get a creature species for our creature species equals world. Get creature species. Next, we'll just get the 0th creature, and we'll say entity creature species equals creature species. Excellent. Oops, underscore. I don't know if the creature component currently has a species attribute. Let's double check that. I don't think it does. Entities, components, creature. No, it does not. So we're gonna say species equals 0. Cool. Cool. So now we'll set the color to be the color of that species. I'm not sure if we set a color. Hang on, let me try. No, right now we're just yeah, we'll look at the torso's color. So say var color equals, and what will this be? Creature species get body part get. Okay, and then we'll say the creature that we want, which is that one, and then the body part will say torso. Cool. And we'll just say that is the torso's color. And actually, this is just torso. Cool. Oh, there. And honestly, let's just say between, we'll get a few different creatures. It'll either be the first, second, or third. How's that? Okay. There's some new kind of, there's a new effect when the chunks generate. They all kind of raise up. See that? You like that? It used to just happen to the plants, but now the terrain and everything lifts up as well, which I think looks really cool. Okay. There's no color here. Vertex argument undefined. So the torso's color is undefined. We're going to look and see body part ID. Okay. Torso. Yep. Torso's color is set. I'm going to print the torso color real quick. That should... Something's not... Creature species, body part get. That's... should be right. Undefined. That's peculiar. The torso is definitely getting a color. Are we not generating enough creatures? Let's just do the first one again. We do have to assign a creature to. We do have to assign a creature for the player as well, which we'll do soon. That is bizarre. Okay, let's print this out. It's a map, DS map print. Cool. Okay. So the what? So the torso is just it just says 2 3 1 2 0 1. What? I have no idea what that means. Okay. Something is wrong here. Okay, world get creature species from index. This returns a creature species, correct. Okay. Let's print out the creature? I have no idea what data structure that is pulling from. I just want to get the color. I think the creature species is wrong. Or the body part is wrong. Or the body part is wrong. Okay, so the creature species is correct. And so that's fine. But when we get a body part, DS map get a creature species body part ID. Super weird. Okay, let's get the head instead. Let's see if that does something different. I'm definitely spelling torso correctly. We're getting the creature species. We're printing out the map, but the map is just weird. It shouldn't be. It should not be that way. Okay, let's get the head. Print out the head. The body parts have way more data than that weird map of values. What the heck? 2 3 1 2 0 1. I have literally no idea what that means. Okay, body part. What? Body part create. See, it's way more than just that. Substantially more than that. Creature species body part get. We give it the creature species. We check its body part map. We give it the ID. Returns that value. What on earth? Okay, let's just print the torso. Let's also put the torso back. Hello there, Mr. Popo Man. How are you? Welcome to the stream. Do I know you? I think you're new here, unless you're in the Discord and have a different name. Hopefully you're new. Welcome. My name's Devin Martin, developing at Middle Realms. If you are in the Discord, then you already know that, and that's embarrassing, but you know, either way. Oh man. See, I need to make it so that it's locking the mouse even if, and I can still look around even if I'm in the pause menu. That's not good. It's fine. Let's create a creature. Crashes, it is 0. Okay, so it's not returning anything. You can't seem to sleep. Oh, why is that? And where are you located? Because oh, you're null. Okay, yeah, hi null. Got it. Okay, so wait a minute. I did figure out the problem here. Creature species body part get. Torso's not coming up with anything. It's returning 0. So, oh, How the heck was this function working before? Okay, this is wrong. So we're going to get the map. Var map equals that. Okay. Right, yeah. I know the time in Australia. Just didn't know that you were null. Okay, it should work fine now. Whoa. So, I am creating creatures, but I don't see them, so that's kind of a problem. Oh, I'm not birthing the creature. To explain it. So we're going to say entity, entity, birth, entity. Simple enough. And that function places them into the world. I can call entity unbirth to just pull them back out, and then they still exist, but they just don't exist physically. They're in like a weird realm. Okay, let's say boop. We got a creature. Boop, 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 boop. We got some creatures here. Excellent. They're so laggy. So I'm going to make them move more smoothly, because if we're going to be animating them, this type of movement's not going to be very nice. Also, let us pick from 1, 2, 3. That should, I just want to double check, that's going to give us 3 different creatures. I'm fairly certain that's going to work. Excellent, it does. Okay. So that's good. You know what, actually, I would rather do right now than the creatures? So, oh, this is actually kind of a cool environment. So right now the mushrooms and whatnot, they can't actually interact with them. I want to be able to highlight this mushroom head, hit E, and have it pop off. But I cannot yet. Or I can, it just doesn't happen. Oh, I love these trees. So I think I kind of want to work on that first before the creatures. I think the spheres should be a little bit smoother. Here, let's look at this island pop up out of the sea, shall we? Everything's gonna rise up. Maybe not. Maybe that's as far as it's gonna generate. Whatever. Okay. So let's put a hold on the creatures, and let's do the highlight plant parts. Generate fruit and flowers, because right now the fruit and flowers on the trees are not generating. I would like to fix that. So firstly, each plant needs to hold a list of its various points, which it does not currently do. So what we're going to do is go into plant parts, instance, flower. This does not happen right now. I'm also going to open up the canopy. We're going to drag those into the same window, pop that up. Okay, canopy goes first, because it generates first. Okay, so, firstly, the canopy generates fine. It's just a matter of its points are not being kept track of at all, I don't think. Yeah, no, they're not. They really should be. So, are we saving the segment? We are saving the segment. That's good. And since we're saving the segment, we should be able, the idea is that, so a segment in my 3D graphics library is just an array of 2 values, 2 numbers. And between those, if you were to iterate through a list of vertices within a 3D model, this segment would hold a segment of those. So for example, the tree, the entire tree is one 3D model, and a segment could be any part of that 3D model. So in this case, the canopy segment is just the vertices that make up the canopy, and I'm saving that into this instance part, which should be called entity part, but whatever. I'll go globally replace the word instance with entity later. Then, when I access the canopy, I get its segment, and I pick a random triangle from that segment. But the issue with that is something. I don't know what it is, but there's strange problems that arise whenever I do this. I will demonstrate. Sometimes it just crashes, unless it got fixed somehow. So yeah, see, there's a bunch of different colored flowers on this tree, and some of them are on the trunk. So it's definitely not working properly. I don't know where the... Is there a set? No. I don't know where, I think, so we're using this function to access part list. Entity plant part list. Let me look at this. No. Oh, well, you know what? I'm saving the segment like that. That's probably an issue. It is for sure. Okay, so it's actually a pretty simple fix. I don't save a segment in here. It happens externally, which is really good. It should be happening externally. Let's see if that solved the problem. That right there may have solved the problem, because there's a wrapper function that executes all the others. Oh, that didn't work at all. That executes all the generator functions for the plant parts, and that wrapper function automatically keeps track of the segment. Only it doesn't. Oh yeah, no, that that is problematic. Yeah, so let me grab. And honestly, this is. Oh no, I remembered. I'm. Okay, we're good. I'm mumbling like a madman right now. We're gonna grab this. We're going to get the chunk, or the model actually. This, because of the model, there's actually, I lied, because there's not, the tree is not a model. The entire chunk is one 3D model of all the trees. And that is how I'm able to achieve 20,000 trees at 100 frames a second still, because I'm only drawing like a few dozen models instead of 20,000 models. Is going to work? Ah, I think it's working now. All these trees have sort of tealish gray flowers, and they're all on the canopy. Fantastic. We should be good now. One thing I love the idea of is fruit growing off of tree trunks. So real quick, I want to check to see if all I have to do to get the flowers to grow on the tree trunk is to change this to trunk. I think that's all I got to do. And the flowers will occur on the trunk. This can be a species-specific thing, so that this species, right now I'm hard-coding it, but in the species generator, yes, it works. I think that's really neat. Let's let this generate out, because there's a lot of plants that are about to spawn. This is a very dense area. I want to see how it handles it. Appears to be handling it perfectly fine. Little mushrooms, a sword. Yeah, it's a little bit volatile, kind of really quickly. But man, look at this. I've been wanting to achieve this level of density in the forests for a long time, and I'm finally able to. Yeah, look at that. It's perfect. It's a little bit slow, but it's partially because of the streaming. Whenever I show anyone, whenever I screen share, it always kills the frame rate. So hopefully that's why. All right, cool. Anyway, mission successful. I want to change this back to the instant parts. I think it's just called anchor. We'll see if that works. Should always be on the canopy, but the anchor in this case is either the canopy, the canopy. I can make that sometimes be the trunk. It might crash. Oop, it didn't. Okay, cool. That is what I called it, the anchor. Cool. Alrighty. No, I have an awful computer. It has an integrated graphics card. It's like $100 desktop, so it should run fabulously on other computers, and I've ran it on even worse computers than mine, and it runs totally fine. So, I can't even play Minecraft, you guys. Like, if I play Minecraft, it has to be like on the all the lowest possible graphics, and it's still really crappy. So, let's clamp this real fast. We can just use the editing chunk global variable. It's the chunk that we're currently editing. Cool. Okay, what am I doing? Fruit fruit now. Same process. We're not getting a segment. Let's make the well. I don't know if now is the best time to do that. I want to make the fruits not just spherical. I want to make them other shapes, but I don't even know what other shapes to make. I want to make. I don't have a way to generate a torus, like a donut shape 3D model. I want to have torus shaped fruit. I think that'd be really funny. I'm not ever using the segment, so I'll get rid of it. Uh-oh. What? Okay, don't know why that was even executed just then. Oh, I hit backspace and I meant to remove that, but I hit backspace on the game and I tried to spawn in a creature. Okay. Here comes the world, get ready. Whoosh. That looks awful. Ah, it works on Linux. Cool, we have fruits now, yay. I'm gonna make it so that very rarely they spawn on the trunk. So if I go into the species, I can set, I'll do a weighted choice here. And this is very simple. Basically, we give it a value, and then we give it a frequency. We'll say this is 75. Let's say it's 80. Let's say it's 90. And then the plant part type trunk 10. Okay, the fruit's anchor point needs to be the same as the flower part's anchor point, which we'll say anchor. It's that easy, you guys. Okay, cool. I don't even need to test that because it's just going to work at some point. Sweet. Let's just really quickly generate a few different types of fruit. I know it's totally off topic, I just really want to. So we'll say plant part shape equals choose. We'll do a weighted choice. And we'll say, so first of all, sphere is pretty straightforward. That'll be, well, for now I'll say 75. And then here we'll say cone. Nice, yeah. Well, to run a server, you need to run the game right now, unfortunately. We'll also do a cylinder. We'll say that's like 25 as well, whatever. And what other shapes do we have at our disposal? We'll have cubic fruit, why not? But that'll be quite rare. Cube, 10. Okay. Plant part is upside down equals choose true, false. Cool. Cool. All right, now when we actually generate the fruit instance, we're going to get the shape. Get these upside down. Is upside down equals instance part is upside down. Cool. The Z will say plus height times is upside down, which this actually needs to be yes. Okay. Now we're going to switch for the size, or no, I'm sorry, for the shape. A switch statement is just like sort of like an if statement, just with a lot more just better conditionals. Really, it's faster. So if it is a sphere, we do a sphere. Simple enough. Literally exactly the same as this. And we got a cylinder, cube, cone. Okay. If it's a cone, if it's a cylinder, if it's a cube. Alright, so this is the same set of cone. Radius, height, triangles, we'll do 12 triangles. Color's the same, only difference of the cone is we have to say times, and we'll say times bool sign, because we want this boolean to be converted to a negative 1, 1 instead of 0, 1, and this will be negative bool sign, I think. Yes. Okay. And then that's fine. Same exact thing with the cylinder. Oopsie. And the cube is a little strange. I hate doing the cube. So we're literally going to say minus radius divided by 2, minus radius divided by 2, minus height divided by 2, radius, height. Or, yeah, height. There's no triangles. Cylinder does not need that many polygons. Yes, you'll be able to climb, for sure. Have you played Breath of the Wild or seen the Breath of the Wild's climbing system? That's kind of what I want to be able to do. Procedural animation, climbing, that kind of thing. Should be pretty cool. Okay, let's see if we get any cool fruit. Okay, this mushroom is right on this other mushroom. That's should not be. Okay. Here we have some cylinder. Oh, I can't fly right now. Shoot, that's right. That's fine. Those are spheres. What do we have over here? These are flowers. Not a huge variety in trees right now. I do really like these red ones, though. Those are cool. Yeah, so the climbing in Breath of the Wild is really neat. I'd like to replicate something. I'd like to be able to come up with something similar to that. Okay. Well, we're not finding any. Let's do one more generation. Oops. Let's actually just, for the heck of it, remove. Where am I? No. Yes. No. Where is this? The heck, yeah. Let's remove the sphere as an option just for right now, just so we only get weird fruit. Ooh, pink grass. Come on up. Okay, higher variety in plant life here. Lots of flowers, no fruits though. Come on, mature plants. I see. Oh, interesting. So this species right here, this yellow with the sort of purpley grayish stalk, has flowers on the trunk. That's quite rare. I don't know why there's so many on the bottom. I don't know if that's just by chance. I'll have to look into that. But then the fruit are the fruit are like discs because they're cylinders, but I'm not capping them off. I forgot to do that. Let me quickly do that right here. I have to just say that the cylinder creating caps equals true. Okay, let's keep looking though. Let's keep looking. See some fruit over here. What are those? It's too high up for me to tell. They're so small. I can't tell. What else? What else? What else? What else? I want to find the fruit for these trees. I see lots of flowers on these sort of cubey trees, but I don't see any fruit. Okay. I see some fruit over here. Oh, it's so back and forth right now. Okay. Oh, what's this? Cubes. Okay. Cubes. Oh, more cylinders here. Yeah, they'll be capped off now, and those are flowers. Cool. Well, this is fine. This is an interesting environment. I like this. It's very strange. Ooh, I like these mushrooms too. Look at that. Okay. It's hard for me to actually develop this game because I spend so much time just walking around. This is a problem. For some reason, some of the time, and this is a great mushroom, but that's actually 2 mushrooms. I'd like to be able to have more detail on mushrooms like that, like the 2 caps. But that's 2 mushrooms in the exact same position. Same with this case here, which I don't know why that's happening, but it shouldn't be. I have no idea what's happening right here. No idea. I'm at a loss for words for what's happening with this right here. I think it's 2 mushrooms. Yeah, there's a green mushroom and a brown mushroom. Okay, whatever. Cool. Let's try to find a new species of tree. Look at this guy. The issue, and it's not really a problem, but the world is so enormous. I think these are new. Are these new? No, I guess not. The world is giant. I mean, it would take hours and hours and hours, like 10 hours probably, to walk all the way across it. And because of that, I'm able to really make the environmental conditions change quite slowly. So if you're in a particular area, I mean, imagine being in the Amazon rainforest and just keep walking until you're in like a different environment. It would take quite a while, and that's kind of the case usually here. So, and that's not necessarily a good thing as a player, because it's hard to actually, because like there's, I mean, right here, let's see, there's like 1, 2, 3, probably 4, maybe 5, about 5 different tree species, but it generates like 60 of them ish, like between like 30 and 60 every game. So there's a way deeper variety of plants here in this world, but we can only see this many right now, which is fine. I think I gotta make the world smaller. Anyway, oh, that's fine. Yeah, so one thing I need to do is, Game Maker doesn't really handle garbage collection very well. And so my computer's gonna die for a second here, but yeah, the chunks when they delete don't actually free the memory, so I need to make sure that that's happening. Anyway, come on, close out of there. Close out of there. Cool. So, what are we doing again? Okay, we want fruits to get highlighted. Let me grab my cell phone real quick. Hello. Okay, so is Game Maker collaborating now? Okay, cool. So, we're going to need to make a new component. Oh boy. This new component is going to be called interaction regions. Okay, and then we'll give this component to the plants. Well, honestly, we can give this component and subtract this component dynamically. Also, we need to have a list which will, upon creation or initialization, let's hear interaction regions. Oops, let's actually just copy another init component script. That'll be easier. This will be event interaction regions, and this maybe this shouldn't be pluralized. It'd be easier to just oops. Oh my God, can you work? Thank you. And this will be region. Cool. And we're going to initialize the list. Interaction region list equals yes list create. Excellent. So now what we're going to do is, well, we want to create some component-specific functions. Okay. We're going to say interaction region, and we're going to say entity interaction region add. Simple enough. And we already have a function for this, so we're going to just steal that. But it needs to be almost completely rewritten because it was used for instances, Game Maker objects, which we don't use anymore. We use our own system. So I feel like I can just do this. I don't feel as though a separate function for this is necessary. The ID, I'm just gonna, okay, so this will be, oops, no. We don't want that, we want to close out of that. We want this function, correct? Yes, correct. So in this case, we want to, firstly, add an interaction region, and we're going to say, oh no, add the interaction region component, and we're going to say entity component. Well, yeah, component add. We're going to say if not component has entity component int has. What? That's it. Oh, entity has component. My God, I apologize. Now we're going to give the entity and interaction region. And we'll add it. Entity, add component, entity, interaction region. Okay, and upon calling this function, we'll also be calling the init function for this component. So the list is now created. And now what we can say is the ID can be equal to the entity plus the DS list size. This is underscore entity interaction region list. Excellent. Absolutely fantastic. Remove this. I want to add the interaction region to the list, so we're going to use this list. Fantastic. We're not going to add it to the chunk, correct? Or do we add it to the chunk? Yeah, we should probably also add it to the chunk. Okay. Chunk add interaction region. That works exactly the same. That is unchanged. Okay, cool. Only this needs to be that. Oh gosh. This needs to change too. Dot instance now needs to be entity. It's fine. I want to find the definition for this. Enumeration. Sweet. All that's good. Excellent. So now what we're going to do, close everything, and we're going to set interaction regions for, or rather we're going to add them to the mushrooms, I guess, right now. It'll be the fastest way. There's more mushrooms than fruit right now, just usually. So we'll go into plant parts instance. This will be renamed to, well, yeah, entity. And we'll say generate cap. That's the part of the mushroom we want to add the interaction. Do we need to save? No, we do not need to save the segment. That is already done. Okay. This is a little bit more complicated. So, okay, we're going to firstly, we're going to call entity interaction region add. We're going to give the entity, that position is the same, x is the same, all this is the same. Yes, that's fantastic. We're going to add a highlight index to the model, which will basically say these vertices. Oh, I see why I need to do that. I see why I have to get the segment. Oh, we're good, okay. These vertices in the head have this special ID associated with them. And then the instance parts interaction region gets set there. Excellent, okay. Now, all that we have to do, you know, this might work, like off the bat, maybe. This might already highlight as is. We'll see. It might also crash the game. We'll see. Come on up, world. Woo! Okay, yeah, I was a little bit dubious of that working. That's fine. It's fine, fine, fine. So in the game event, updaters, play, interaction scanning. So let's see where, yeah, that's the problem. Oh, no, it's not. We're not going to look at that right now. That's interesting because this pretty much should be working. Oh, that's not correct at all. Let's say plus. I think right now it's just 1.5, but that's very hard coded. Gotta change that. Anyway, let's see what we get here. So this might actually work. It might have been an issue of that issue. Let's see. Ah, well, would you look at that, you guys? My God, that was incredibly easy. No way. Okay, sweet. Yeah, it's a little off, but it doesn't matter. Oh, cool. The cylinder fruit now have, yeah, bottoms. Okay, cool. So adding this to the fruit should be just as trivial. Just copy that. Same for the flowers. It should all be exactly the same. Let me just do the fruit and flowers. So we're going to go into plant parts, flower. I can just paste that in there. Only difference will be we want the segment. We want none of that. We want the radius. That should work. Fruit is again slightly different. Overwrite that. What's everyone's favorite movie? I've been watching kind of a lot of movies recently. Okay, so our segment. I do this for all the different generative processes. Boop. Oops. Boop, beep, pop. Okay, segments there, radius, that should all work. Okay. I did a lot of setup before with like the actual highlighting in the shader and whatnot. I'm not actually touching any of that. That all stays exactly the same. Come on up. Whee! Okay. You highlight flowers. Excellent. Flowers highlight. Mushroom caps highlight. The fruits highlight. They... Really? That is your favorite movie? Okay, I've never seen that. I should try it out sometime. I'm too short to reach anything. I see some fruit way down there, I think. Those are probably flowers. Oh, here's some nice low fruit. Boop! Fantastic. Fantastic. Now, if I hit E, it's going to crash the game. Oh, it didn't. Okay, whatever. Either way. Oh, yeah, of course not. So, I need to make these fruits harvestable. Honestly, I'm probably just going to wait to do that. I'll wait and do that once the creatures are set up a little bit better. I'm very happy with how quickly that was. Oh, nice. That's fun. My favorite movie is maybe Once Upon a Time in Hollywood by Quentin Tarantino. I love Quentin Tarantino movies. Django Unchained, The Hateful Eight are great. Deadly Liars is like heavily inspired by The Hateful Eight. I don't know if anyone ever made that connection, but it's like the same thing, kind of. Just a game version. Look at these. I don't think I like the cubes. Maybe like very rarely that would be cool. Like 1 out of every 1,000 plants has cube fruit. Ha, little tiny guy. That's so funny. I feel good about that. Okay, I'm going to grab a special drink. It's not special, it's just a soda. And then we're going to resume on the creatures. We're going to do finite state machines. Dynamically weighted finite state machines. I'll be right back. Boop, boop. Okay. So, let's do a little bit of AI architecture, shall we? I had an idea. Hey, Gabe. Let's go into the ideal software for AI architecture, Paint. Actually, you know what? Let's go into let's do something different. Let's go into the PPG Google Drive, shall we? And we're going to go into Middle Realms. we're going to create a new thing. Oops. Okay. That's great. Oh, okay. I want a diagram. Yes. Yeah, whatever. I said AI. Okay. Okay, cool. Boop. So we have a state. This is the idle state. They are doing nothing. Well, yeah, we're just gonna remember that that's what that means. Cool. We have a wander state. Wander. They are walking around randomly. We want to be able to pass between these two states. Sometimes. Boop, 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 whatever. This line will be. How do I make it double lined? How the heck do I? Okay, I'll just do this then. Fine, be that way. Okay. I think we finished the AI architecture. No. Basically, I want a way because so a decision tree. Is a little bit too finite to make me comfortable. I need a way to have a check for certain, for having certain behaviors. So for example, let's have, okay, no, when I hit enter, I want it to be done. But it just moves down the line. Okay. Get food and drink. Okay. So we obviously need certain triggers. Oh my god, if I press enter, I want it to be done, but it just moves down the line. It's so frustrating. C, target. Okay. And so, no. Oh my goodness. I'm a little bit upset with this UI. So yeah, whatever, we see a target and we oopsie. And if we're hungry, then whatever. Same thing here. Oops. Although, you know, ooh, interesting idea. We could have substates, not substrates. That'll be when we're doing farming. So let's delete everything for a second. I have an idea, a totally different idea. So we have a idle. Whoop. This is big. And in there we have stand still. We have wander. We have sit down as options. Okay. And because like regardless, we're pretty much, I guess, I don't know if I want to do this. We're pretty much doing the same thing regardless. We're just idle. No, finite state machines all the way. This is too complicated. No. Dynamically weighted state machines, I meant to say. So instead, we have some events. We have idle. Not events, behaviors. We have wander. We have chase. Wait, just whatever, attack. These don't have to be. We have flee. We have garden, or farm, whatever. These are not in any particular order. They just exist. Okay, sure. Let's put them in here, though. Oh no. Is there a way to move it back? Can I? To back. Cool. Okay. Excellent. We have these random states. Unordered states. Cool. We then have a decider. Ooh. Sounds scary. Checks state and decides which to execute. No text, please. Okay. World state. Okay. With that node. Cool. Something like that. I don't want the transitions to be linked to the states, really. And this is pretty much with the AI. This isn't really going to be how the player works. The player is going to be... the player's behaviors will be divided into states as well. But they won't really be, the player is the decider, not, there is no decider AI. Oops, okay, cool. So, yeah, let's do that. First of all, I want to set up the player's AI a little bit better. Not the AI, is no artificial intelligence. We just want to have some states. So we're going to make a, I guess the creature could have states. That seems fine. And we'll say states, creature states, whatever. What are my options? Free. Okay. They are free, which is equal to 0. Do the same thing as the other definitions here. We need an animation component would be kind of nice to have. Okay, whatever. Because the player is a creature, and they can take from that. Okay, yes. But is the player a creature? Yeah, they must be. Cool. Let's go into player create for a second. That's not what I meant to do. Go there. Thank you. I'm going to set the player's creature. So we're going to say player creature species equals world get creature from index. Uh-oh, what's that called? Creature species from index. Ooh, okay. Whatever. That's good. Now we have a creature. Or now we are a creature, rather. So maybe the player should also have a state instead. Now the player can just use the creature's state. It's fine. It's fine. Whatever. So in the events, in the player's update event, we will switch states. Switch state. and we'll say switch entity creature state. Cool. Yep. So we'll check for free. Creature states free. Great. And we'll execute the various components, which will happen just like this. Okay. Fantastic. And that's done for now. Pretty simple, actually. We need to get the other, well, how many other player state components are there? We can't jump right now, we can't fly or anything like that. Harvest, hold, drop, strike, all that stuff will be later on. For now, let's just get the AI for the, well, let me make sure this is still going to work. I want to make sure we can still move. Well, wait, you know what? We move way too fast right now. When we're running, let's move it through 33. When we're walking, we walk at 33 divided by 2. Why not? Should be a little bit better. Should I put on some music? Come on, world. Whee! It's better. Running. Yay. Can't jump yet. It's fine. Still working? Oh no. What? Why can't I highlight that anymore? Why can't I highlight that one? Why can't I highlight this one? Oh no, what? No. Why can't I highlight that one? Oh no. Can I highlight this one? Is it like this species is screwed up? Or is it the chunk that I'm in? Those are fine. That little guide is fine. Why do you do this to me? Is there any way to get you to highlight? Is there any kind of weird? Okay. I have to look into that. In the meanwhile, I'm going to add a size component. Decision what size. And that will be 111. That's fine. The player will be set the size. We'll say size x equals 0.5. Size y equals 0.5. And size z equals, you guessed it, folks, 1.5. Okay, and now when I'm there's a few things I gotta do. For one, the game state updater here, which is probably going to end up going into the player object. Yeah, I should probably go into the player object. I could do that right now. By player object, I mean player component, but whatever. I'm going to do that now. Oh, it's fine. What does this do? Nothing, that's fine. Okay, that needs to go to the player component update event. I'll do that down here. I'll make a region for that. Region. Oops. Region. Interaction raycasting. Okay. End region. Cool. That's fine. I just need to see. Yeah, that's. Oh no, this will be entity. Honestly, I should probably pass entity into these as well. I'll do that later on. Okay, so that's good, I think. This needs to be plus entity size z. That will be rewritten completely. Well, I'll keep it commented out for now, and that should be fine. Then just the camera's position needs to be set. Camera. Oh, what? Ah, there we go. Cool. Everything should work exactly the same as before. But now it's a little bit better. Come on up. Yay. Hello, ooh, a big patch of mushrooms. Okay, cool, it's all working the same as before. Fantastic. Really wish that other mushroom that one time got highlighted, though. I don't like that it didn't. Cool, cool, cool. Okay. Let's check the state before we do anything. Check game state. If game get ooh. Game state get? Does that do that? Okay. Where what the heck was I? Here is equal to play. Yep. Exit. If not that. Now my mouse will not be stuck when I'm in the pause menu. Yay. Whoa. I'm in a tree. Okay. Ooh, look, a cone fruit. Very nice. Okay. Very cool. Look at this forest. It's so dense. Man, the frame rate's plummeting from screen sharing. It's fine. Cool, cool, cool. Alright, let's get out of here. How much am I? Ooh, interaction region is... Oh, range is 10. That's whatever. Let's make that shorter. Let's make that 5. Okay. Regardless, we're going to continue on. I don't want to run that. Okay. So we have a behavior component, right? We did that. We need a... Yep, cool. We need a behavior map. So do we want a map? I'd rather not use a map if I don't have to use a map. Yep, we have to use a map. Map 0. Okay, and at the init function for the behavior component. Sorry, the init event for the behavior component is going to create that map. I love this component system. It's so much fun to work with. It's so nice and decoupled. Alright, so the create the map, we literally just say simply behavior map equals ds map create, and that's all there is to do. Fantastic. Fantastic. Okay. So now, let's make a behavior thing here. Behavior. This needs to be, well, yeah, I'd like to keep all these uppercase when I can. Cool. So we're going to say entity. Oops. Add behavior. I'll say, yeah, behavior. And let's also rename this add interaction region. Well, nah, let's keep it the way it is. We'll say behavior add. Cool. Brand new function, ladies and gentlemen. Takes an entity and a list of behaviors, but we need to also pass data for those behaviors. So that's fine. We're going to allow any amount of behaviors passed. We got the entity, and now we have to actually figure out how we're going to pass the behavior. So we need to create a behavior. Create behavior map. Well, it's yeah, behavior. It is a map, isn't it? It's called a behavior map. Whew, whatever. Var behavior map equals ds map create behavior map. So no, we need to iterate first. Iterate through arguments. Var I equals 0. No, it equals 1 because we are already getting the first argument up top there. Lower than argument count. We want to iterate through all the arguments. Get data var behavior data argument I. Fantastic. Now we'll create the behavior map. Oops. Create behavior, whatever. Behavior. And yeah, let's have behavior create. This will just be a very small function. Create behavior var behavior equals argument 0. No, ds map create. Behavior type equals. Let's create a behavior enumerator. Behaviors enum. Oops. Enum behaviors. A lot of few. Wander, well, idle, oops, idle, wander, chase, whatever. Just create a few just off the bat there. I guess by default it'll be behaviors, idle. Storage, be another DS map. Oof. We're getting pretty heavy on the data structures, so we're gonna have to. And that might be it. Yeah. Return behavior. That just feels a little better than doing it in here. Okay. I'm going to say behavior create. Okay. Behavior type. Oops, that's not how that works. Type equals behavior data. 0, yep. And now we're going to iterate through the given data. Iterate through given data. Well, honestly, I can't give it specific data because it's not going to actually matter now that I think about it. In 10 rings it mattered because the creatures were a lot more gamey, but now it's not going to work quite like that. So we're literally just going to have a list of behaviors, I think, and a behavior map. Yes, that is actually that simple, which I'm quite happy about. So we're literally going to say behavior. It's quite a lot lighter weight now, which is nice. I'm used to programming 10 rings stuff. This is a little bit more abstract, which is both fortunate and unfortunate. Add to map. So do we even need a map? We don't even need a map, do we? We just need a list. Just need an array behaviors, which doesn't change. And honestly, now that I think more about it, I don't even really know if we're going to need a list of behaviors. Because, okay, right, so 10 rings. I gave every monster a list of behaviors. So, like, the scholars had the flee behavior, whereas the ghouls don't flee. So I had to explicitly say, okay, yeah, the scholars have the flee behavior, the mimics have the mimic behavior, and they have the flee behavior, and their flee health threshold is 50%, whatever it is. But it's a little more abstract than that in Middle Realms. I can't really say that because I'm not defining each creature. So now that I really think about it, I don't think we even need to have a behavior list at all, because all the behaviors are on the table. The current behavior is decided by that creature's like physical attributes and its situation. And that'll happen to be a decider. So I don't think that I can even add behavior because there's none to add. There's no need for a behavior map. Pretty nutty. Okay, so we need memory. That needs to be a map. But besides that, we don't really need anything, which is kind of weird. So whatever, that's fine. In the update function, we need to execute different behaviors. I'm going to subdivide these. We're going to break this into two parts. Decider, executor. Cool. So right now, we're literally just going to say, oh, well, we need a state. Yeah, I think that the... All right, I want to give the player a state. No, it's not going to work. Yeah, okay, whatever. It needs to stay on the creature. It's fine. I don't really want these to be very coupled, but whatever. We're going to say entity creature state is equal to behaviors item. Okay. Now, how are we going to do this? I guess we could switch behaviors. Actually, it's fine, whatever. I'll figure it out. Switch. Idle case. Behaviors idle break. Fantastic. So I'd like to make this behavior system, I'd like the behavior to be compositional as well, so that we can share some amount of code. So the way we're going to do that is have a bunch of behavioral functions, and in this case we do none of them. Well, we're gonna basically pass, because when there is a creature that is idle, at least right now, they're literally not going to do anything at all. When they're wandering, though, they're going to wander around. So we're going to call entity behavior. I want to call them parts, or maybe behavior what? I guess component, but I don't, whatever. Yeah, component. Wander. Cool. So in that case, what we're going to do, entity will pass an entity as well. Entity. Get arguments. Our entity equals arguments 0. Cool. Search for a point. Okay. And we're going to say entity behavior memory set. Okay. And that function is going to set apart the behavioral memory. So in this case, we need to pick a random point to walk to. We need to remember what the point is. We have to walk to it, and then we have to pick a new point and then remember the new point. Pretty straightforward. So we're going to say we give an entity a key and a value. There needs to be a memory key and a memory value. We get the arguments. Cool. And we're going to get the behavior memory. So var memory equals the entities behavior. You guessed it, folks. Memory set memory. Memory key equals value. Simple enough. Sweet. So, we're going to say memory. We call this set memory. It's kind of the way I've been doing things. And we're going to say has memory, gas memory, has memory. We don't need to pass a value. We just want to return, check. We want to return whether or not we have this. So return, we don't know what to do this. We can just grab that. Say dsmap exists. Key. Cool. That just returns whether or not we have the memory. And finally, we want to get the memory, which is pretty similar to this as well. Only we are going to get the map like this. And, oops, I don't know why that happened. And we're going to return. We're going to return the memory. All right. Let's have an underscore here. Sweet. We have all of our memory functions, and we want to remove a memory. We'll say remove memory, and then we'll really have everything that we need. And we're going to say dsmap remove, destroy, delete. Okay. All right, we have all of our memory functions we could possibly ever need, I think. So we're going to get So we'll use all of our, pretty much all of our functions in this one line, not one line, this one block of code. If there is not a behavior memory entity, so if there's not a wander point, we want to set one. Var x equals entity position x plus random range, and we'll say we want to wander between 6 and 24. We'll do 4 and 24 units times choose -1, 1. We're going to duplicate that, and we're going to change that so, excuse me, and we're going to set the memory. So we'll say entity behavior. So we find a position if we don't already have one. Set memory. We want the entity. We want it to be called wander point, and it's going to be the x and the y. And we have an array position here. Get, okay. Get a new, and we're going to say get the current target position. Well, wander point. We're going to call it wander point. Cool. And then we're going to call entity behavior get entity wander point. Excellent. And we're going to move towards the point. We're going to say var. We're going to say var dx equals distance cos cosine whatever the speed of movement, which right now will be 0.1. And the angle we have to, yeah. So we're going to calculate the direction. Var direction point direction. Let's do 2D right now. It'll be our position. And then the wander point 0, wander point 1. Fantastic. This will be direction, so we're just creating a movement vector, essentially. Well, it's not essential, it's just what it is. dy. Excellent. And we're going to move. We're going to calculate. Ooh, and actually, I can make a vector, right? Vector 3. Do I have a... I think I have vector functions here. Yeah, I do. Vector 2. Oh, right, it is a vector 2. Ah, yeah, let's just do that. That's perfect. And then what's vector step do? Yeah, I want this. I want it to work this way. I forgot that I had these functions here. Hello, where was I? Okay, so we're going to say var vect equals vector 2. We're going to say this. And we're going to say var move equals vector. I wonder if it do that automatically. What is this? Let's say that. Let's, oh no, that's not gonna work. Yeah, let's do this. Heck were we? I just close it now. Okay, whatever, it's fine. And I'll say vec, and I'll say 0.1. Excellent. Now we don't have to do any of that. Sweet. How about that? Entity position x plus equals move 0 y 0 1. Okay. That's cool. All right. Now all we have to do is actually go to that behavior. I'll say wander. We have to pass the entity, and we'll be ready. And we should. They should. Oh, forget one step. Well, we're not forgetting. We're just not doing it. We are not looking for a new position once we've already found one and moved to it. So watch. Once this guy comes up here, I'll wait for the world to generate a little bit and then pop him in. He should move to a position, and once he's there, he will stop, and he will never move again. See? Problem. So rather than do that, we're going to delete, remove wander point once we are there. So we'll say if point distance, actually we could say if vector vec dis is lower or equal to 0.5, we will remove it. Entity behavior, remove memory, the entity and the wander point. All right, we've used all of our memory setting, getting, removing, adding functions. And now the creature should move towards the point. Once they're very, very close to that point, they'll pick a new point to walk to. Hello? Oh, I am an AI genius. Cool. So that's happening fine. Fantastic. Cool. So I have an idea. So basically, normally in a normal finite state machine, in the wander component code here, we would check. So at the, I would write something like, if chance, 25% chance, state equals idle, something like that, right? So there's a 25% chance that we'll now go to the idle state and we'll just stand there. And then over in the idle state, we'd say something like, oh, there's a 25% chance that we'll move to the wander state, and they kind of bounce between each other. I don't want to do that. So that's what the decider is going to do. That's the plan anyway. So that's not what I wanted to go to. This is. So what I could do is have a message system. Yeah, I could have a message system so that the entities can send messages through each other and other entities, so that I can say, hey, I just found a new position to move to, and next frame I'm going to move towards it. Then the decider can look at that and say, oh shit, there's he's at a good point to stop moving for a little bit. Let's do that 25% of the time. But this system's a little big, but it does need to be here. So we're gonna do this. We're gonna say entity messages. Boop. And I'll put it there. Whatever. Cool. Cool. Entities have to have a message list by default. Message list. This is not a super list as much as I love my super lists. This is just a normal list. Cool. The message list is not going to be copied at all. We're just going to make a new message list. Cool. And honestly, we should probably do this after the fact. Set entity default data. We should do this if we don't, because right now we're creating 2 lists, and that's bad, 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 bad. Okay, sweet. All right. Anyone have any questions about Middle Realms or development or anything? Happily answer any questions. All right, so we have a message list. We're gonna just put the well, yeah, whatever. I'll messages here. So we're gonna have entity send message. Cool. Well, actually, yeah, that's fine. I want to be able to pass the messages around. So maybe I should make a different function, like an entity message create, and then we send one of those. Yeah, we'll do that. Entity create message. And that'll be a type. And it'll be data. Cool. Cool. Data 1, data 2, data 3, data dot dot dot. So var message equals ds list create. Okay, we have a list. I want to return the message. Oops. We want to add message data. This is not a list, this is a map. Okay. For var I equals 1, I lower than ds, no, argument count. I plus plus. This is a big C, we need a little c. What just happened? Okay, there we go. Get data. Var data equals argument 1. Cool. And we're gonna just set. We're gonna we'll just say var key equals data 0 value add to map. Oops. We'll say add to message. Message key equals value. Cool. Is all that good? Nearly. Oh, we're not setting the type. Message type. We have to make a message type enumerator. Do that real quick. Do that do it down here. And the messages, we'll say behavior report. Cool. And now we need to send one, we have to get one, we have to has one, we have to remove one. That's fine. So let's actually kind of build this as we go. So move wonder point, create and send behavior report. Okay, so we'll say var message equals entity create message, and we're going to say that the type is messages behavior report. And one bit of data is let's say found new wonder point. That's fine. I think there's going to be enough of these that a string works fine. Let's say entity send message. Message. No. entity message. Cool. We of course need to create this though. We're going to take the entity, let's take the message. Entity message. We'll add it to the list. Add the message to the list. Cool. Cool. Entity. This would be this list, right? DS list create. Add entity message list message. Cool. Simple enough. Although becomes problematic because well, we can't have two of the same message at once, right? No, we could, I guess. We could. And the message is not stored very smartly. We could use a super list for this, but super lists are really big. I'd rather not have a super list on every entity in the world because it's thousands and thousands and thousands of lists at that point. So, computation versus memory here. For now, we're going to iterate through and check each type, whatever. Has message. Okay, and we're going to say type. Type. Iterate through each message. Get message list. Var message list. Iterate for I equals 0, I lower than ds var message number equals ds list get. This should be not that. This should be entity message list. So message list. Message number I plus plus. Okay. Get new message. Our message equals message list. Hey Lucas, what's up? What's never been done before? I don't think I looked over or saw your message for a while. You mean the AI? Number check type. If message type is equal to type, we'd like to return true. Cool. And then message get is almost an identical function. Only it returns the actual message. Cool. We just need message remove. The super list, yeah. A super list is just a data structure that I made that it's literally just a list of lists, but it's very optimized to be a list of lists, and it's very nice to access different parts of it. Like I can just say like value equals super list get, and then give the super list, and then give two indices, like which list and then which position in the list. When I was first making it, I was like, oh no, I'm just making a grid. But yes, super list is what I said. I was like, oh no, I'm just making a grid, but no, because each sublist within the super list can be a different size. A grid, each column has to be the same size, or each row has to be the same size. Not a super list. It's super. Okay, but for real. So, we're going to say, okay, we're going to say, so this is kind of, again, pretty, this is definitely going to change. We're going to say if chance, well, we're going to say if, we'll switch state. Switch state. We should just copy the switch statement. All right, if chance, 100, 1,000, whatever. Well, yeah, fine. We'll say that this. Let's make a method for doing this. A function, whatever you want to call it. In the behavior, we want to say entity behavior set. How are you doing today, Lucas? Anything with your retro PSX game? Entity state. I'm getting tired, you guys. I need a break soon. Getting a little loopy. Good arguments. Sparse. That's not nice arguments at all. State. We're going to set the state. Cool, we'll do more with that later on. Updaters, please. Events. Yeah, okay. We'll set the state. Entity. Behaviors. No. Behaviors. Wander. Cool. And then we'll say. We'll say if entity has message entity, and the type will be messages. Oh, cool. Cool. How's class going? Alright, so whatever. 1 out of 500 times the creature is in the idle state, they will become in the wandering state. If they're in the wandering state and they send a behavioral report, regardless of the data within it, it will transition back to the idle state. So, no index. I should read more. I always just ignore my errors. I'm just like, oh, I'll figure it out, and then well, that time it worked. What? Oh, when they change to the idle, when they change from idle to wander, it will crash. Yep. Message number, ds list, get. Yes. I'm using the wrong function. This is has, and so is not gas. I keep writing that. And also in the get, which is right. Entity messages. Has get. No! DS list size. God. Okay. Alright, that should be good now. Make a few of them. Okay, they're gonna move, and then once they get to a position, it's gonna crash. Perfect. Our message equals. Oh, right. Okay. So there needs to be a pipe there and a pipe there, because it's not an array; it's a list. Because arrays suck in GameMaker. Okay, let's see here. Boop, 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 boop. Hello. Everyone's undefined. Message has. Is there what? Message list. DS list size. Message list. It's saying that. Oh my god! I'm doing really bad. Really, really, really bad. Obviously. Okay, please stop moving when you get to your location. Ah! And then you'll move again, correct? You'll move once more? They're doing it. I can tell that they're doing it over there. Ah, you moved a little bit. Why'd you move a little bit? Oh, interesting. They're only moving a little bit at a time. That's really funny. Okay. Nearly there, guys. Is it because we're removing the wander point? We don't have it anymore. So we should be getting a new one. We're creating a new vector to the wander point. That's weird that... Oh! Yeah, because we're not actually removing the message. So we always have the message. Okay, I'll do that. I am in need of a break because at this point I keep messing up and I'm tired and I want to go walk around outside. So thanks for watching, everyone. Definitely stream the same time, probably longer tomorrow. I might even stream later this afternoon. Thanks for watching, guys. Don't forget to subscribe, comment down below, join me on Twitter, join me on Discord, whatever. See you guys later.